Hi, we are in the 8th International Meeting on Plant Breeding at Exalt, Universidade of São Paulo at Piracicaba. This year's edition, the theme is AI for Scientific Breakthrough, Applications and Innovation.
Several professionals in the field are here today to be refreshed on these modern tools which are becoming more and more applied in genetics and plant breeding projects. To find out more about this topic and the experiences of those who work with it,
check out now this interview that we did with one of the speakers. Hello everyone, we are here with Julian Garcia. Julia is a PhD student in data analysis at the Center of Biotechnology and Plant Genetics, the Politécnica University of Madri, as well as a resident in artificial intelligence at Google. Hi Julian, welcome to Brazil. Thank you for accepting our invitation. It's a pleasure to have you here.
Thank you for having me.
And first starting, I would like to ask you to tell us about a little of yourself, your career, and your path in science.
Okay, so my career, from high school, I kind of like both mathematics and biology, and I had clear that I didn't want to become a doctor. So biotechnology seemed to be the way to go. But once I was there, I realized that wet lab molecular biology was not my thing. So I had to decide between plant production or computational biotechnology. And I chose the second. I was going to choose the first, but my father, who's a farmer, told me, I think it's better to go the computer way. So I did. I learned how to program in Python, and I graduated. And after that, I was quite tired of science, so I did a master's in artificial intelligence without any kind of biological information there. But after that, I don't know. I returned to try to combine agriculture and artificial intelligence in plant breeding. So I started a PhD in quantitative genetics and plant breeding at the Universidade Politécnica. That's kind of my story.
And in your opinion, what are the perspectives in genetics in plant breeding in the next year?
Okay, this is hard to answer because there are many breeding programs in the world, public and private, and they are in different stages. Like some of the programs have already introduced genomic selection, they are using that in their pipelines, even more advanced tools. Some of them are starting to work with that, and some of them are totally like they don't want to do it. As a cutting edge technology or what's in the top, I guess it's modeling things that are not additive, and being able to model them and to use them properly in breeding programs, but also non-genetic things. I think that environmental covariates are going to be really important in the future for predicting new environments. Even if we have plants in one environment, due to climate change, we don't know what is going to happen in some years. So it's good to have a metric relating this kind of temperature, rainfall, to allow us to know what's going to happen next year. So I think it's going to be more with environment and GVA interactions than actually genetics. I think the tools are already really good, and the data and the protocols are also established. So I think we have to push a bit through the multi-omics thing, but we are far.
Perfect. And how can we integrate the use of artificial intelligence in developing sustainable products?
Well, we listen a lot that artificial intelligence every day, but for me, this is just a tool for making decisions. So we, the people, we have to to make the decisions. So artificial intelligence should just be a helping tool. Like it should help us to decide what to do in the context of building programs. Yeah, the main application I would say that is, well, I guess automatization too, but the most important tool is the prediction. We want to predict lines, we want to predict climate, we want to, in general, predict what's going to happen in the future in order to make decisions. For me, that's the point. Having something that allows us to say, okay, we are going through this path, not because intuition, but because we have data driven, and we are doing data driven decisions. In that sense.
And what are the main challenges when working with large multi-omic data?
Okay, yeah, that's true. Well, the thing with multiomics is that every data set is collected kind of independently. So first of all, imagine we work normally with tabular data, things that we can store in an Excel file in a grid of columns by rows. But even with that, we have many different factors. We have genotypes that are characterized by markers. we have environments, we have plants, we have many things that are different levels of different factors. So first of all, the main problem is to organize that, to harmonize that. Because yeah, you may have some genotypes, but some of them might not be phenotype, and the other way around. So we have to remove first in one side, then in the other side. And when you harmonize everything, you reduce a lot of the data that you have. So you need to know when to impute, when to discard data, when to assume that you will have some missing data. That's hard. Yeah. And then relate everything, put that in a database, and even being able to model, that's also hard. But for me, the data preparation and the exploration is the worst part. Modeling is always nice.
People say that preparing your data is where you took most of the time.
Yeah, 99%. There is no package that is going to solve your problem. Like once you have the data formatted, it's really easy to run a model using a package that is already done. But the harmonization for me is the what puts you close to your data. Like, this is my data.
You work at the Moonshot Factor at Google X. Can you tell us a little bit about it?
Yeah. So Google X is a division of Google, and it's called the Moonshot Factory because they aim to solve problems that affect a large part of the population. So these are really moonshot projects. It has a probably more riskier approach than other projects at Google. So the potential gain is bigger, but the risk is also really big. So it was hard to work there in the sense that you don't know what's going to happen. You have really long term but crazy goals, and you have to work day to day. Like you see how you complete the small achievements, but it's hard to see or to project what is going to happen in the future. But it was a really funny place to be. I really appreciate that they hired me and they had me there. I had the opportunity to meet a lot of brilliant people, develop my career, and in general, I learned a lot. Yeah, it was also my first experience in the industry, and it's pretty different from academia. Yeah.
Speaking of which, what are the main differences
Oh,
between the academic environment and the industry?
okay. The day to day, oh, of course, at the end of the month, the salary. That's crazy, but you know that already. But in the day to day, what I felt there is that I was working for stakeholders. I had to deliver a product. Like people were expecting me to collaborate or to contribute to a product, something that can be sold. Here in academia should be similar, but our incentives are different. Like we want to publish. For example, when I'm doing my research in academia, I get the data, I train my models, I prepare the paper, and once I publish, it's like this is knowledge. This is going to be here forever. That's all. Let's move to the next project. In industry, you have to think a bit more about okay, we have a solution, but we need to deliver it. We have to do the marketing, we have to sell it, and we need to keep the revenue coming. It's a longer streamline, I would say. And another thing is that well, once you are in academia, you forget a bit about publishing, so you kind of disappear from the academic work, which is extremely competitive. You need to be there publishing, being in on the spot. So that's if you don't mind disappearing from public life, I guess it doesn't matter. But if you are aware of that, I think it's hard to leave academia. So that's a point.
Like I heard someone told me that in the industry, like you deliver like a thesis for in a month, for and
Oh
it's
no,
like
I wouldn't say it's like that. Delivering a thesis is really demanding, and work is demanding as well. But it's a different kind of approach. It's a more work day to day work. In a thesis, you have kind of, for me, in my opinion, you have long term goals and you see months coming and you have an advance and it's like it's coming and in industry it's more like we have to do this way this week this month this year it's another also you have more management you have more people running ruling what you are doing so it's pretty different.
so that. Thank you for your time, Julian. That was the interview, guys. Don't forget to subscribe to check the other interviews, and we see you next time.